Okay, so now that I get the thing electrically repaired, or so I believe, I've got to test it because I'm not sure, with the complete absence of that squelch potentiometer, I'm not sure how it's going to act. So what I got is I got my Optimus brand subwoofer satellite speakers that I used to use on one of the kids' PCs, but they kind of outgrew it. So this has got a line input on the back. So I've got the line out from this going to the line in on this. Of course, I'm just going to get one channel because, well, it's I got one channel coming out. Test. Testing 1 2. Testing 1 2. Testing 1 2. All right, that seems to work pretty well. Testing 1 2. Testing 1 2. Test test test. All right, everybody. So I got the SC61 Sencore waveform analyzer all hooked up, and I'm going to use this to demonstrate the difference in the signal strength between the line level and the microphone level. Okay, so first we're going to do the line level, and what I've done is I've taken the output from our uh, receiver for the wireless microphone, and that's the line level. I've got the volume cranked all the way up, and I've got the scope probe hooked up to that output. So if we turn on the receiver, which I've got the receiver turned on, I'm going to turn on the transmitter. And the pattern you're seeing right now on the display is actually a waveform of my voice. So if I whistle or do a tone, I can actually get almost a sine wave. So I'm going to increase the um, volts per division setting and just kind of get an idea of roughly what the amplitude is that we're dealing with here. So if we look at this, I've got it set at half a volt per division, and we're pretty much peaking out at just about 2 divisions. So I'm just about 1 volt peak to peak, maybe going up above it a little bit here and there. And I actually have the waveform analyzer actually also can display the peak to peak voltage here, but on a pattern that's moving like that, of course, it's you know you can't really get a good reading. Now, if I had a steady tone that I could inject into here, then by all means I could definitely get a better reading. Right now, I'm holding the microphone pretty close to my mouth. Let me put it back down. Um, put it on the area of my lapel, which is where it typically should be, according to the instructions that Radio Shack has online for this setup. It should be 6 to 8 inches from my mouth. So now you can see it's dropped down a bit, and let me just give a steady tone. And it looks like we're probably around 0.65, zero point 0.7 volts peak to peak. But you definitely, you could definitely see it. And if I go down to a lower setting, like say zero point 0.1 volt per division, now you can really get an appreciation for what the waveform of the human voice looks like. Now, keep this in mind because I'm going to now switch the setup over to the microphone, and you're going to see how little the amplitude is coming out of that microphone. All right, so I haven't changed the setting here, voltage peak to peak. So this is a cheap microphone that came with my son's karaoke set, but it actually works perfectly fine. So I'm going to speak directly into the microphone. Testing 1 2, test test test. So I'm speaking at a pretty good level and right directly into the microphone. I don't know if you can see that, but that's barely moving. So I'm going to come down to the lowest setting we have on the voltage per division here, which is 0.05 volts per division. test, test, test. And you can just see it just moving. So it's definitely getting a signal, but the signal is so low that it's barely registering. And furthermore, we're getting a lot of noise now. Now, if I had this on the line level, it would be huge right there, that waveform. So you could see there's a big difference in the signal strength between the two. And just to satisfy my curiosity, and those of you viewers who are wondering, well, maybe it's the microphone.
Testing 1 2, test test. Testing 1 2. Testing 1 2.
So there's nothing wrong with the microphone. That's the normal level that comes out of a microphone. It's so low that the scope can barely register it. So you can imagine if the GoPro's audio circuitry is expecting to see a level as tiny as that coming at it, and instead it's seeing a level that's like 10 times as strong, it's really kind of being overwhelmed. So there's probably a lot of automatic limiting that's doing its job, and that's probably the only reason why the audio was half decent at all when I first tried this thing. But I think what we'll do is we'll try an attenuation circuit, and we'll see what the audio is like after we do that. All right, back to work on the microphone adapter. So I decided I'm going to use the U-pad design here. Okay, just going to cut to the chase. I was going to try the L-pad, see if it worked, and if that didn't work, I was going to use the U-pad. But I figured, well, there's probably no bad thing that's going to happen if I just go right to the U-pad design. So what the hell? It's only going to cost me one extra resistor. All right, so this is the design I'm going to use. So I'm going to put this circuit in somewhere. Now, where do I want to put the circuit in? Well, let's put it this way. This is the receiver over here. And it's outputting a big signal. Okay? And what I'm going to do is I'm going to send it into my attenuation circuit and turn it into a little signal to go into the input of the GoPro. All right, so you see, got a big signal coming out of this. I'm going to shrink it down with the attenuation circuit and to a small signal and into the GoPro. Now the reason why I made this cute little diagram is because I have a decision to make about where I want to put this attenuation circuit. Okay, in other words, I've got an RCA line out. I'm splitting it into two RCAs, two channels, going over this cable, and then going to this adapter. So if I put my attenuation circuit over on this end, okay, effectively I'll have my attenuation actually happening closer to the receiver. Okay, the reason why I don't want to do that is because the distance that the small signal coming out of the attenuation circuit has to travel to get to the input of the GoPro is longer if I do it that way. And if I do it so that my attenuation circuit is down near this end, okay, over here, then the larger signal coming out of the receiver is doing most of the traveling, and it's being cut down only right before it gets into the GoPro. Why is that important? Well, it has to do with signal to noise ratio. So the higher the signal to noise ratio, the better. So let's pretend we're looking at the window of the oscilloscope, okay? And if we had no signal present, say no one was speaking, the microphone wasn't picking up any audio, there's still some background noise that's going to be on that wave present there, okay? And the idea is that the larger the signal is that's coming through here, the more masked or hidden this noise is going to be. So if the amplitude of this noise, let's say the amplitude of this noise is roughly this, all right? Well, if the amplitude of the audio signal riding over this noise is large enough, then this noise pretty much is hidden. But if we have a very small amplitude signal that's closer to the amplitude of the underlying noise, well, that can be a problem. So we want a high signal to noise ratio. We want a large signal compared to the background noise. That's happening at the output of the receiver. And so I don't want to knock that signal down really low right off the bat, because then it's more likely to pick up noise on its travel through that cable. So that's why I'm going to put my little voltage divider circuit here. I'm going to put that near the end here. Now, I already talked about how I'm not going to cannibalize this cable. So I could cut this plug off right here. But I don't have a lot of these cables, the 3.5mm stereo to dual RCA cables. So I'd like to try and save that cable in case I need it for, I don't know, I think I might have a video camera that uses this. So I don't want to do that. So instead, what I got is I got a cheapy pair of headphones here, okay? And this broke on these. So what I'm going to do is I'm going to cut myself a 3.5mm stereo plug off of there. This becomes trash. Now I have this RCA patch cord, stereo patch cord for RCA. So what I could do is I could run this into the circuit and then run it into, I could tie these two, I could cut this off, tie these lines together, have two lines going, and then continue to use this at the other end. But I really don't need to do that, because what I can do really is I could take this patch cord and just turned it into two monos. I only need one. Okay. So what we're going to do is this is going to go directly into the back of the receiver, and a high level signal is going to come out of that, a mono signal. It's going to come down the pike to this end. It's going to go through the well, here's another decision I got to make, and I'm not quite sure how I want to do this. Do I want to split this into two legs and send it through two voltage dividers? Probably not. Probably just going to take this mono signal, send it through the U-pad, have it come out of the U-pad and go to both the left and right channel of this cord here, which will go into the GoPro. Well, I figure that I'll try that and we'll see what happens. Nope, I'm going to have to report a fail. This is okay. I was able to strip this. Got myself two good connections. I twirled all of these copper strands together. Once I tin them with solder, that'll keep those at bay. And I can work with this cable. My problem is my 3.5 millimeter plug that I tried to steal from that headphone. That set of headphones is so cheap and cheesy. This cable is so thin. These are like whisper strands. I don't even know if that's even copper. This shield looks like it's copper, but these other, the left and right denoted here by the green and red, I don't know what the heck's going on there. And this appears to be some sort of a monofilament nylon. That's exactly what that is. That they've infused into the wire to give this thing a little bit of strength because it's such a cheesy cable. It's horrible. So I'm going to have too much difficulty trying to actually thread onto or solder onto these. So what I need is I need a dedicated 3.5 millimeter jack with terminals that I can solder to. And I happen to be going to the city tomorrow for something else, and I know that there's a electronics store in the city that may very well have exactly what I need, and probably for a couple bucks I can get the plug and just make my life a lot easier than this garbage. Oh well, I guess I won't be finishing this tonight.